Hi everybody, welcome back to China Manufacturing Decoded from the Sofeast group. This is episode 194. We are closing in on the big 200. It's coming soon. And today we got a bit of a British takeover with myself, Adrian, who's hosting, and Paul Adams joins us on the pod today. You've probably heard from Paul before. Paul's one of our senior engineers in the group. And well, we are covering a topic today which very much needs an engineer to explain it. So, Paul, how are you doing?
Well, hello, Adrian. Yes, good to be back. Doing very well this end, thank you. And almost 200 episodes. Can't believe it. Can't
I
believe it.
know, I know. It's
Nice one.
we've been going since around the time that COVID started. That's when we started doing the podcast because Renault and I were discussing, how do we get a lot of people are being affected by COVID, maybe, in lockdowns and things like that. How do we get information out to the world? And podcasts seem like a good way to do it. And here we are years later and still going. And sometimes, people are sending us messages monthly and they're saying, oh, thanks for covering such and such a topic, or can you cover this topic? So it's really nice that people are getting value out of what we're doing.
Absolutely. Absolutely. And talking about people requesting, so Gillian have set up their own plastic molding shop, and one of our clients asked us about surface finishing.
Hmm.
So I talked to them regarding their particular products and the needs of a surface finish and what that meant. And that sort of triggered this particular topic with respect to surface textures on molded parts and how to actually get that surface texture into the mold tool itself. So that's what we're going to be covering today.
Yeah, that's a good topic because you might not even think about it a lot of the time, but every product almost that you're touching, or, it could be your car outside, or I just bought an iPad and bought a case for the iPad, which has got a texture on it. Uh, these don't just come by accident. These are, adding a texture to a plastic enclosure, for example. This is something that has a purpose behind it. There's a lot of thinking goes into it, and it's and that's the process that we're going to be going through today in some detail, right?
Well, we're not going to go too deep, but I think there's plenty of sort of content to discuss. We can go as
Great.
deep as we want, sort of pun
Okay.
intended, as it were.
Sure.
But yeah, definitely. So to kick off, basically, I want to cover sort of when adding texture to a mold tool, there are a number of different rules with respect to just general rules to keep in mind. So you need to consider the purpose and the function of adding texture to your product. Now, let's talk about the product itself. Now, that could be a requirement to have it non-slip, for example, or totally the opposite way around, a slippery surface. You may think, I've got a product in front of me. It doesn't have a surface finish. Well, it
Mm.
has. If it's a shiny product, we talk about the iPad. I've got an iPad in front of me. If you look at the back of that, that is a very highly polished, okay, it's a metal product, but the casing I've got, some of that is very, very smooth. Other areas are very rough and tactile.
Mm.
So, it could be aesthetics, right? It could be a more of a functional aspect on why you need to put a texture on a product. Okay.
Sure,
And you
sure.
need to actually understand what your product is in service for, and then look at what type of surface finish you need on your product. And then you can start to understand how to actually apply that surface finish to the product itself. Okay. And
Mm.
we're going to go into that in more detail as we move forward with respect to some of the ground rules, with respect to tooling, and what is required to add texture to the tooling itself.
Mhm.
But you need to step back to start with, from a design aspect, you need to really understand why you are putting a texture on your product.
Mm.
I want to talk about the iPad case that serves a two purpose. One is aesthetics. It makes it look different and makes it look good. But two, it actually, in my case, I like to feel as if I'm in control of the product I'm holding. I don't want it to feel slippery. I don't want it to feel as if I'm going to drop the product because it's too shiny or too slippery. So that acts
Mm,
as two things. It's aesthetically pleasing as well as acting as an anti-slip or a gripping surface. Okay, so that's
mm,
important. That's important to understand that. Okay. And then you need to understand what type of texture you want to add. Now, is it a smooth surface? Is it a deep, rutted surface? Is it a complex pattern? We've got some geometric shapes you can apply to, surface finishes. You can have a random pattern. You can have alligator skin. You can basically have anything you want. So it's
mm,
really a case of looking at what pattern you need with respect to what you are trying to put across. Now, I've worked with a number of clients in the past where they want to imitate an animal print, an alligator skin without actually going into, using, skins from an animal, which is, that was their thing. They wanted to actually imitate that particular pattern
mhm,
for aesthetics reasons, or that's one of their selling points. So you can actually have any pattern you want, and that is applied through various different methods. Again, I'm going to cover that as we move forward. So another thing to really look at is if you're getting a texture added to your product, you need to look at the cost of application. Okay, so the
mm,
cost of application is different with respect to the process or the method you're actually applying the texture to the tool. Okay, so if you've got a relatively inexpensive product, an entry level product, let's say to the market, and you're looking at a highly complex texture, that may add a lot of cost to the tooling, which may be prohibited to the process itself. Yeah, and the end product.
mm,
The cost may it might not stack up, let's say. And you also need to look at making sure that you've got consistency as well, with respect to the product itself as in coming out of the tool. Now, again, there's some general guidelines that we need to understand as engineers as we're designing this product. There are certain guidelines we need to understand when we're applying different textures. Okay. Now, if you've got a
mm,
shiny, smooth surface, right, that can be as problematic as getting a textured product out of the tool, believe it or not. But anyway, let's move on to some of the general rules with respect to designing and considering the different types of texture on the tooling itself. Okay,
mhm,
so we've covered the initial part with respect to why you would want to add texture to a product. Now let's look at it from a designer's aspect. When you're sitting down doing some design work, you need to do some general rule of thumb guidelines. Okay,
mm,
so when we're looking at tooling, there's general rule of thumb with respect to draft angles. Now, a draft angle, you can imagine when you were sort of back as a kid, you were doing sandcastles on the beach. You had
mhm,
your little bucket, right, and you filled it up with damp sand. You turned it upside down. You smacked the bucket with your little spade, and you pulled off the bucket, and there was your sandcastle. If you noticed that sandcastle was not perfectly parallel up. It had an angle on it. Yeah.
mm,
And that is what we're calling a draft angle. That as soon as that bucket released the side of the sand, there was a gap, right? And that allowed for, in our case, the ejection of the plastic part out of the tool itself. Now, if you've got a very shallow angle. In other words, it's almost parallel. The walls in the tool are almost parallel, and you want to put on a relatively rough surface finish. As the part is ejected out of the tool, the sides of the plastic injection part is going to scuff against the tooling sides walls. Yeah, and therefore it's
okay,
going to damage your surface finish. It's going to damage the texture. So therefore you need to add a relatively steep draft angle, same as your sand bucket, in your sand castle, in
Hmm.
order for that to be ejected out of the tool cleanly without damaging any of the texture as it comes out. Okay.
Mm. Okay.
So depending on how deep your texture is, depending on how much draft angle there is. Okay. And now the general rule of thumb. So the standard draft angle is 1 to 2 degrees as a typical um, draft angle for a light texture, right? And this will allow your product to be ejected out of the tool cleanly without any scuff marks.
Hmm.
Okay. So that's a
What is a what is a light texture? If we can just try and visualize what you mean by that.
a light,
Typically.
yeah, a light. Well, again, I'm going to talk in technical terms. It's like
Yeah.
a light spark finish. Um, for cool, blimey, it's
What about a brushed finish, like brushed aluminum or something?
yeah. That's
Okay.
a good analogy. That's
Okay.
something you can picture. Okay,
Yeah,
so
yeah, yeah,
yeah,
yeah.
it's
I think most listeners can probably picture that.
yeah. If you're basically touching a light texture, you can feel it's textured. Yeah, you can look at it and it's got a dull look to it. It's not a shiny finish. Okay, but it's not coarse and you can't feel the bumps in it. Okay, so that's brushed aluminium is a good way to visualize that, Adrian. Well done. So that's your light texture. So you're talking a depth of about 1 to 5 thou or um 0.025 microns.
Wow.
It's small. It's a very, very small texture. Okay. From a depth point of view. If we step it up a little bit, so a moderate texture, so you're talking about 5 to 10 thou, uh, in those terms, you are needing to add a greater draft angle in order to maintain that texture integrity. So we're stepping up from 1 to 2 degrees to 3 to 5 degrees total draft angle
Mm,
in order to get your product out of the tool without scuffing or damaging the surface texture.
mm,
Again, if we step it up another level, we're talking about a heavy texture around sort of 10 to 20 thou. That's coarse. No, that's coarse. And I'm gonna go through what coarse and fine is a little bit later on. See if we can try to understand that a little bit better.
okay.
But again, we're talking about 5 to 10 degrees. You can imagine 10 degrees. This is your sandcastle bucket angle. This is quite severe from a draft angle point of view. But in some cases, that's what we're looking at. And we're talking about wood grain finishes and complex geometric patterns, for example, that really need to be maintained as they are being ejected out of the tool.
Mm, okay.
Okay. So the general rule of thumb, when you are sitting down doing your design work, don't forget, don't forget to add your draft angles onto your 3D CAD models. And if you can work on 1.5 degrees per thou, that would be, that'd be okay. When I'm talking about per
Right.
thou, that's like the texture depth.
Yeah.
Okay. So that's your texture depth. You'll need 1.5
Mhm.
degrees. That's your general rule of thumb, you know?
I did, this is good because if let's say you're working with a Chinese manufacturer and they're going to help develop your tooling
Yes.
and they're playing a bit fast and loose with this stuff and just saying, yeah, yeah, it's all good. And they don't mention this. Maybe they do include it, but maybe they just haven't mentioned it. But if you're forearmed with this information, you can go to them and say, okay, talk to me about the draft angles, please, because we've got to get this texture right.
Yeah, indeed. That's definitely a good advice, Adrian. You should always be discussing capabilities of the tool maker of your components and your parts, and draft angles is a key aspect, particularly when it comes to ejecting the component out of any tool. Right? And particularly if you want to maintain that sort of complex, really fancy surface finish you've got on there, or whatever texture. So,
Mm,
which is
mm.
very, very important.
Yeah, I follow you so far. Good explanations. We're doing some visualizing here, but that's
Good.
okay. all right. On to the next point then. So this is how we actually add that surface texture to the plastic mold tool.
Yes, let's talk about that. Yeah, there are various different techniques. Some of the techniques have progressed from the early days and got fairly complex nowadays, because the technology has moved on from the 80s and the 90s. Giving my age away, when I first started engineering,
Hmm.
way back then. So these days, the technology's sort of very cool, a lot more advanced than what it used to be, but still a very good practice for putting on finishes is the first one. Let's talk about sanding and polishing. You will see this in every single toolmaker's workshop throughout the world. Okay, this is a traditional method, and it involves very, very skilled engineer sitting down, hand polishing surfaces, and that will make them glass-like. Okay, it's very
Hmm.
time-consuming, labor-intensive, and back-breaking work. Still done today, right? And this is done for high-gloss products, um, smartphone casings, anything that needs a really, really good high gloss finish. You will see people hand polishing, hand sanding tools in any workshop you go to. So
Wow.
that's the first way to do it, sanding and polishing. Second way is spark erosion. Okay, so this is a method where we've got electrical spark which erodes the mold surface. Generally, these tools are done in a bath of water or oil, and the electrode comes down, which is generally copper. If that's a flat surface on the electrode, that will impart a flat surface onto the mold tool. Now, the way it works is an electrical charge will touch onto the metal, and that will break down the surface of the metal and break that away. So basically, it's removing metal from the tool. Now, depending on
Hmm.
the shape of the electrode, that will be imprinted onto the mold tool itself. Okay. Generally, spark erosion is for not necessarily textures, but deeper pockets or things like this, keyholes, and particular shapes, more of a shape generating aspect. But it can be
Hmm.
used in some complex patterns or logos, for example. You'll often see spark erosion carried out where we've got a logo, okay, sort of embossed or
Okay.
debossed on sort of the tool itself. Another way is blasting or media blasting. This could be sort of sand or grit or a finer metal sort of grit. And again, if you got a highly skilled operator blasting this, you can actually get a very good pattern across a uniform area of the tool itself.
Hmm.
This is commonly used on a lot of tools where we got a textured grip. For example, you've got some of the sports equipment got a grip finish on some of the handles, or even decorative finishes on appliances. A lot of this work is done via blasting a media, a shot media over a surface area of the tool, and the tool can be masked off. So you've got particular areas showing that you're actually blasting itself, where everything else is like masked off and not affected by the blast area itself. So again, this is a very relatively quick
Hmm.
and easy method, and again, a very common for the uniform texture, which is not complex. It needs to be. We're going back to the light texture, light to medium
Hmm.
texture we talked about earlier, where the brushed
Hmm.
aluminum. I've got a speaker in front of me. I keep on picking this up because this has got a really nice light spark finish. Going to a light spark. That's my old sort of engineering speak coming out. It's got just a light and I believe this could have been done by this media blasting technique. Because it's got a
Okay.
uniform finish to it. It's not rough. It's just taken the edge off the shine. It's got a dull look to it. Really nice.
Mm.
So that's a
Mm.
very good sort of way of doing it. Now, if we're getting into sort of more complex shapes and textures and everything like this, we're looking at chemical photo etching. Right, now, this method is one of the newer methods, and it's become probably the method or the go-to method. And it involves applying a photoresist film to the surface, and then ultraviolet light cures that area, is then washed away, and that is then etched into the mold itself. So you can
Mm.
have a very complex and versatile pattern. And this is where you get your animal prints. This is where you get your geometric shapes. This is where you can get any complex texture that you want. Okay, because again, you can just put that on. You put the film on. You can cure it with the ultraviolet light. You wash it away, and then it's etched into the mold tool itself. And again, this is a relatively quick way of doing it, and accurate as well, and a very uniform process. Which,
Mm.
if you look back, if we go back a couple, and we're talking about sanding and polishing, that's a human sitting down polishing this. That is very, very specific with respect to what they can do. Okay. If we're looking at blasting, and we're looking at blasting a particular area instead of very small areas, chemical etching itself is very specific, very unique, and very it's a desirable way of putting on any texture you want onto the product itself. Go back to
Mm.
my iPad, for example. The case that I recently bought it's got cross hatching on it. It's got a leatherette finish on it. It's got a smooth finish on it. It's got so many different textures on the surface. There's no way that that's going to be sandblasted. That's going to be chemical etched into the tool itself and done that. Now, this is the go-to most popular process of adding any textures to the tool itself. An example of products that use this would be a watch dial, where we've got intricate lines and shapes. Textured grips on any of the electronics. Like I just said, my iPad case has got so many different textures built into it. This would be the perfect process or methodology to actually add those textures to the tool itself. And the leatherite finishes is exactly what I've got in here. And we're looking at larger areas as well. Can you imagine sort of your luggage that you go on holiday with?
Mm.
The outside of that has got a uniform pattern or a texture. You can bet your bottom dollar that was done via chemical photo etching on the tool itself instead of
It's
anything
a
else.
it's a big old mold, that is.
It is, yeah, but it's not some of the biggest ones that are
Mm.
out there.
Sure.
If we step it up a gear, and switch into the automotive industry, for example, you've
Mm.
got all sorts of trim and panels inside you've got the dashboard, probably one of the biggest trim or panels that is inside an automotive sort of product, or a car or a truck or a bus or something like this. If you look at your dashboard, yours is going to be very similar to mine. It's got a pattern on it. Whatever that pattern
Mm.
is, whether it be a rough, whether it be sort of leatherette look, it's got a uniform pattern over that entire surface, and that entire surface is a large surface. Now,
Mm.
they talk about sort of chemical etching as being the go-to for the general process and the general tool making. Once we step it up to size, we're looking at some very large tools in order to get some of these trims out for the automotive industry. we start to look at laser etching. Laser etching is a step up from an expense point as well. Not
Mm.
necessarily from the tool itself, but the process. You need the equipment. The process of laser etching is not a cheap process. Consequently, it's used for the mass production. The automotive industry is a mass production industry, and consequently, they can actually look at these more expensive processes because it makes sense economically. It makes sense to do that with mass production or a greater number of products coming through. And again, we're looking at a laser beam. Literally, there's a laser moving over the surface of the material, removing certain areas of the material on the tool itself to expose or leave the desired texture that the designer has put into the CAD file itself.
Mm.
Great for that. And laser etching is also used in some of the medical industries, like the medical implants or biocompatibility textures, for example. That is, again, it's very specialized, not a cheap process to use. And this is why it's really used on the extremities of the industry itself.
Hmm. Okay. Yeah, these are some interesting ways. I mean, I assume with things like laser etching, then this is going to be more automated than done by hand. Am I right?
Oh, very much so. Very much so.
Yeah.
Yeah, once you programmed in the sort of the laser etching, it's going to be more like a robot. It's going to be through like a production line. The tools will come. Well, I was saying that. So once you've got a tool done, Adrian, you're not producing hundreds of tools. You've got to remember this is done on a mold tool itself, which will churn out, potentially hundreds of thousands of moldings a year. So we're not actually looking at laser etching the individual dashboards themselves. It's the metal tooling that we're etching into. But you're right, it's very much automated instead of hand done.
Okay, that's interesting look into how the sausage is made, as it were, and I like it. I like it.
Yeah.
No, again, if you look at textures, maybe you don't realize that there's another side to it. How do they even get there? So that's good. So if we move on, then.
We can go a little bit more into depth with respect to how chemical photo etching is done. I'll just give you some quick bullet points with respect to the headlines on the process,
Okay.
because this is pretty interesting. As you say, when I first went out and sat down with my tool makers in the early days, this wasn't around, but this
Mm.
is the go-to process now, one that we're using in-house, one that the majority of tool makers using at the moment. So chemical photo etching is the go-to process, like I said, and it stands out as a popular choice for several reasons. The precision and the detail that you can actually achieve is second to none. Imagine carving delicate patterns onto a cake. Well, you can't do that, but you can with sort of precision, detail, availability on chemical photo etching, versatility. We're looking at the different mediums it actually works on. You can get a pattern or a surface texture on various different metals, including steel, aluminum, nickel, and if you really want to, you can work that on some plastics as well.
Mm. Mm.
Durable. Yeah, for sure. Its etched surface are inherently durable. Is to stand the wear of test of time. So that's always good. And they're also cost effective. The process is very cost effective these days, so which is good. And you've also got the key thing here, I think, is repeatability and control. Okay, so unlike we talked about, sort of the skilled engineer sitting down over a tool, hand polishing, you're always going to get some variability when it comes to a person being in control of the end product. With this, you've got repeatability control of the outcome. So
Mm.
that's basically where we are on why we're doing it. So the process is, I think we've sort of talked about that. We put down the photo resist layer with the texture on it. It's then blasted with UV light. It's then developed through that process. It's then etched and stripped, and then you've got your final product in the tool itself, so which is cool. I want to talk about the roughness itself, and I've talked about the depth of texture. We were talking earlier with respect to making sure that you get your draft angles correct. With respect to the texture depth, we're talking about 1 thou to 5 thou for light texture. Well, what does that mean in reality? Well, in engineering terms, we talk about the RA value. Okay. So, which is basically short for the arithmetic average roughness. So we're talking about peaks and troughs. Okay. So if you can imagine putting a surface material under a microscope and really zooming in, even a smooth surface is not dead smooth. You're going to have some undulations in there. You're going to have peaks and troughs, and the average is your RA value. So basically you're looking at the average of the sort of the peaks, and then you look at the bottom of the sort of the valleys, the troughs, and then you'll take that average, and that is your RA value. Okay, so this is your roughness on your tooling itself. So that's basically what we're talking about, and we're talking about microns instead of thou. Thou being the sort of the English inches, microns being the millimeters and the metric system. We engineers, we always sort of mix our values, I know. But that's a common thing. So basically, a rough texture or a rough surface finish will have a larger RA value, and a smooth one would have a smaller value. Okay, simply because we're looking at the distance between the peak and the trough average. So if that's really small, it's going to be, you can imagine that's a very smooth surface. You've got a really rough one. The distance between the top and the bottom, or the average there, is going to be larger. Consequently, it's going to be a larger number. So we are looking at, for example, a fine wood grain texture might have an RA value of 5 to 10 microns, something like that. Where a stippled grip texture, for example, will have 20 to 30 microns. And this is something that, again, you should really be looking at specifying on your drawing with respect to what is the surface roughness. When we're talking about, what's the finish? What's the surface finish on the product? It's smooth. Yeah, but what is it? You need to specify that, because the tool maker, particularly when you talked about earlier, when we were talking about your Chinese supplier or your manufacturer, everything's up for interpretation. Yeah, if it's not written down, they will see that as an open specification. Yeah, and potentially you're going to come back, well, it's got a surface finish on it, sir. But it's not what I want.
It's not consistent. It's not between batches, for example.
Yeah, or you didn't specify what you wanted. Yeah.
Yeah, right. So it's about consistency, isn't it?
Yeah.
Is it the case with the RA value? Can you have two of the same pattern of texture, but different RA values, i.e. one is a deeper grain than the other one, but the pattern ostensibly looks the same?
You can have the same RA value with a totally different looking texture. That's a true statement. Yes. Can you imagine straight lines, okay, versus a crosshatch? The depth could be exactly the same. So therefore your roughness will be exactly the same. But you look at the surface finish, it's totally different. It's totally different.
Right.
Which leads us really on to the next topic, which is probably the last thing I really want to sort of discuss here, which is specifying what texture. We've talked about this before. Do you want a leatherette? Do you want a crosshatch? Do you want, sort of vertical lines, horizontal lines? whatever the case may be, you need to specify that. So we talked about roughness, which is a very real thing. But then you just mentioned there, Adrian, which is a very good point. You can have the same roughness on a totally different looking surface finish or a texture. And the way to do that is looking at a mold texture book. Okay, so there are a number of different books out there. The one that we commonly use is, wait for it, is the Yick Sang texture book. Now this comes from a Hong Kong company. And this is the one that we use. Now, what they use is, well, they have a book, and there's small plaques of different textures that you can have, that you can specify. And each plaque or each type of texture has a 4-digit code. And in this particular book, they have 240 unique texture plaques for you to choose from. So that is, some of these can be quite expensive, but if you're designing a lot of plastic components, or it's absolutely critical for your product, it's around $500, something like that. So it's something to invest in, but you can actually specify that, and you would be able to put that onto your sort of drawings or specifications, and the tool maker would know exactly what you're talking about. Yeah, because you would specify this is from the Yick Sang texture book, and it is plaque number 234, and this is what it looks like. And you can even take a quick photograph and implant that into the specification documentation that goes out with all your products itself to the tool maker. Another one is the LW texture book. Again, this is a generic texture, a lot of sort of plaques you can find in there with respect to what the different textures look like. And again, you can just cross-reference the exact one in your technical file and send that off to the tool maker to ensure that they know exactly what they are making and building your tool to.
Yeah, these texture books are fascinating because when you start looking at the different textures, you start to think about the things in your life, and you're like, oh, the leather grain that I'm seeing, that's just like my car's dashboard, for example. So it's pretty amazing when you do actually start flipping the pages on these things.
So we talked about making sure the surface texture you require is included in the technical files that are going out to the tool maker. Now, I just want to try and get you a visualization, Adrian, and those listeners out there with respect to what we mean by, I'm going to stick with the Yick Sang texture book, because that's the one that we use in the office here. Basically, I want to try and give you their 4-digit code with respect to what a typical surface finish is. Okay. So unless you've got the book, you don't really understand what it is, but it's giving you an example of the type of information that you need to include in the technical files that are going out. So if you're looking at the Yick Sang texture book and you want a mirror finish, okay, so you're talking about some of the products you're looking around, you got absolute glass finish as a mirror finish. You want to be specifying the YS, which is the Yick Sang reference, and it's going to be the 1286. Now, this will refer to a mirror finish, and it's a super smooth and reflective surface, which is perfect for high gloss products like phone cases and kitchen appliances. Okay, so this is the type of thing we're looking at. And that's a smooth, refined finish. You want to step on, keep on saying this, you keep on to step it up a little bit, make it a little bit rougher. Let's look at some of these natural textures. And one thing that I've mentioned throughout this is animal skin, and I think it's sort of leatherette. So if we look at a crocodile leather, for example, yes, they do that, and this is something that you can specify on your products. If you're looking at, go back to my iPad case again, I don't think it's a crocodile leather, but it's some sort of like rough texture on there. But if you did want that crocodile leather texture on your products, you could actually specify the YS1629. And this is actually a realistic crocodile skin texture which is perfect for adding a luxurious touch to handbags or shoes, for example.
Mm.
So there you
Or
go.
or having an incredibly pimping iPad case.
Exactly. Yeah, exactly. So can you imagine? Why not? Why not indeed? But I want to stick with sort of the natural textures before I go on to sort of something else. You can even have a bamboo green. Okay, believe it or not. So this is going to be the YS1754 bamboo green. Okay. It just shows you the versatility of this particular texture book with their 240 different plaques that you can actually choose from. And this is why, so we advise one, if you're looking for specifics, talk to the experts. If you don't
Mm.
know exactly what to specify or how to specify it, talk to an expert, talk to your tool maker, give us a call. We've got some
Mm.
experience in this. Reach out to us. We can certainly help you get a better understanding of how to specify the textures you're looking for. Okay.
Well, and what's going to be suitable in terms of both aesthetics and functionality for your requirements as well, for your product.
Exactly. Yes, that's
Mm.
right. And that's the next one we're going to be looking at, sort of functionality. We talked earlier a bit about why would you put a texture on a product itself, and a lot of that is because of its a functional aspect. Yeah, most of it is aesthetics, but a lot of it is a functional surface, and it needs to have
Mm.
that correct um, function added to the surface in order for it to do something. Um, and one of those is a diamond grit. It's a very, very specific pattern etched into the surface.
Mm.
And this goes by the code of the YS1815. Now, again, you can look at this particular plaque to see what the pattern is, see how deep it is. In other words, what your RA value would be on and against this 1815 particular grid pattern. And again, if you're looking at the grid or the diamond grid pattern, why is it functional? Because it's a rough pattern. And this is excellent for drainage, ventilation, good for containers, shower mats, something where you need a specific grip because it's a functional aspect of the product itself,
Mm.
instead of being aesthetically pleasing at the
Yeah.
same time. And again, because this is very highly controlled, we talked about how important control and the quality and repeatability and accuracy this particular process is, or putting textures on. We're looking at creative and decorative. So we're looking at herringbone, for example, or a paisley swirl, or a geometric maze. All of these patterns are available inside this book for you to have a look at and go, right, this is the perfect texture for my particular
Mm.
product, and this is why. Okay. And
Mm.
again, it's like each of these patterns of within this book has its own 4-digit code. It's a great cross-reference book if you want to put that on there. So geometric mazes are great for toys and packaging, for example, jewelry that can be used on. Um, and basic, whatever your product is, you need to choose whatever that surface finished is and look at how that is applied to the product. Now, in general, been talking about injection molding, and how to apply that texture to the tool itself. And it's really important to understand the overall picture. We're looking at a holistic picture with respect to why you need a surface texture on your product, how it's applied, what the cost implications are. Is it aesthetically pleasing? Is it a functional surface finish? And you need to understand all of these aspects with respect to the product design itself. And I think that's
Mm.
really where we're talking about from a summary aspect. Okay.
Mm.
And don't forget, if you really do a lot of tooling, a lot of specifying products, it is worth investing in one of these texture books. It really is. They're not
Mm.
expensive. Well, they're not small change, but
Mm.
well worth investing in something like that. If you can't do that, please, please, please reach out to an expert that understands how to specify and give you some guidance with respect to what and how, and some of the technical aspects behind textures on a particular product. And that includes us. Yeah, please reach out to us. That's not a problem. We're here to help.
If you're listening and you do need help, it could even be from you, Paul, if the listeners are contacting us. But I would also add at this point that you've mentioned some of the texture book codes from the Yick Sang book, and if you Google those, you might be able to see them. I'm not promising anything, but I'll try and get images of the examples that you gave so we can visualize those as well. And I'll include those in the blog version of this podcast that you can read on Sofeast.com. And also, we actually do provide texture books as well on request. So, you can totally contact us to obtain your texture book as well.
Yeah, good point. Good point. The issue, it's not an issue. Yeah, it's always good to have a reference point. If you look at something on the internet, it's very flat. You can't,
100%.
You can't feel it. Yeah, you know what I mean? You can see what the texture is going to look like, but it's not until you actually touch it and feel it. This is what I'm after.
And it's worth mentioning then that these texture books is kind of like one of those old school sticker albums you remember, Paul, and and they've got like little tiles of, is it metal? It must be. Is it all plastic?
Yep. No,
I think they're
9
metal,
times out of 10
right?
it's metal. Yeah.
Yeah, they're metal little squares or maybe rectangles in little pouches with the number in the description, and you can actually pull them out, feel them. You can really feel how tactile they are. So you do make a good point, because just seeing them is not necessarily enough, because you actually need to feel the roughness or not the smoothness in some cases as well. So obtaining the book can be very helpful for sure.
Yeah, definitely. So I know I waffle on a little bit, but I'm hoping that gave the listeners a little bit of insight with respect to what texture, when we're talking about surface texture, what type of, how rough it is. It's a lot more detailed than just stating, I want a surface finish. I want a smooth finish. You really need to understand a lot. It's not just about the surface finishes, how it's applied and why it's applied and the function of why you're applying it. So don't forget to specify it. Otherwise, the tool maker in China may actually misinterpret what you're actually trying to say. That's, So I hope it gave you a little bit of insight with respect to the topic of surface textures on tools.
Absolutely. Yeah, a festive treat for everybody, because this one's coming out just 10 days shy of Christmas 2023. So, a lot to process there. And just add it to the list of stuff that you need to be on top of when you're developing a new product, right? There's so many things, and this is just, it's like Pandora's box. Every time you open a little door of one element of your new product, and then all of this stuff comes tumbling out that you really need to think about and know about. But yeah, key takeaway for me is specify. Really important there to get the textures and the product that you're expecting. So yeah, great advice, Paul. Cheers for coming on, and thanks everybody for listening. We will be back next week. Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.